Good afternoon, friends. My name is Zishan, and today I am dealing a concept of relative velocity. Let us consider that we are standing on this road over here, and we are observing these two tow trucks, or you can say that these are the trucks with carrier capabilities. This is truck A, and this is truck B. All right, this is the truck B. Uh, I'm a bit poor in drawing, anyways. Now, if we allow this truck A to move with velocity, which is Va, from the fixed frame of a reference, or the natural velocity of this vehicle A is said to be Va. Similarly, if the truck B is moving with velocity Vb, we'll observe that from fixed frame from the fixed frame we will simply observe that the truck A will move with velocity Va, and the truck B will move with velocity Vb. Now, let us assume that instead of being here, we sit onto this truck A and we observe the truck B. What will happen? Now, from truck A, right? From truck A, if we'll observe the truck B, it will have the velocity, of course, since it's moving with the velocity Vb, it will have the velocity Vb, but since the truck A is also moving with the velocity A in the same direction, we'll observe that the velocity of truck B will be equal to Vb minus Va. Why? Because simply we are on the truck A and it is also moving with the velocity A, so that amount of velocity has to be reduced from the velocity of the truck. Then only the actual velocity that we'll observe when we will be on the truck A is Vb minus Va. And since we are on the truck A itself, the velocity of the truck A will appear to be 0. Now let us say that we are on the truck B. Now we are sitting on the truck B and we are observing the truck A. Okay. In this case, what will happen? The velocity of the truck B. Okay, we are on the truck B, so velocity of the truck B will be observed to be 0, but the velocity of truck A will appear to be Va minus Vb. Why so? Because the truck A is, although it is moving with a velocity Va, but we are also moving onto the truck B with the same velocity, or velocity Vb. Hence, this velocity Va and this is velocity Vb. If you are moving with this velocity, the truck A will be observed to be moving with the velocity Va minus Vb. This is a general case in which, let us say that this is your fixed point O, and this is the point A. This will represent velocity of A. Similarly, from this fixed point O only, this is a point B, and this entire thing is your velocity of B. Now, this section, this intermediate section is, here is your point A, here is your point B. So this is your velocity of B with respect to A. The final point represents the object that is to be observed, and the initial point A represents the object from which we are observing. So velocity of B with respect to A. Now, somebody may ask that what if we change the direction like this? So this will become our starting point, this will become our finishing point. So this will be velocity of A with respect to B. Now here the direction has been changed. That means we are observing the object A with respect to B, and this represents that we are observing object B standing onto the object A. Now, what if these trucks, instead of moving in the same direction, they are moving in an arbitrary direction within the plane? Let's say this is O, this is A, this is velocity of A, this is B, and this is your velocity of B. So simply join these two endpoints such that if you draw the direction in this way, this will represent velocity of B with respect to A, which is given by, of course, VB minus VA in the vector form. Or you can also draw the direction upward and write here velocity of A with respect to B, which is of course given by velocity of A minus velocity of B, right? So this is the concept about the relative velocity. Note that this point O is a fixed point and this point A represents the magnitude of velocity of A from the fixed point. Hence, this VA is an absolute velocity of the track A. Similarly, this OB represents the magnitude of the velocity of B, and VB is the absolute velocity of the truck B. Whereas the length AB represents the relative magnitude of point B with respect to A, or A with respect to B, based on the direction. Based on the direction. See here, the representations are made that this is always the fixed point which is initially mentioned, and this is the final point OA. Now here, if I'm calculating the velocity of A with respect to O, velocity of A with respect to O, this is velocity of A with respect to O. So this will be in this direction and this will be VA with respect to O. Note that the velocity of the object that we are calculating has to be at the end, whereas the frame of reference from which we are observing has to be at the beginning. So thank you.